Hi everyone. All right, so we're going to talk today about section 533, day 2. So yesterday we kind of went through the long way of redrawing the similar triangles to show how you could set up the proportion. Today we're going to kind of talk about what pattern we saw so that we don't necessarily have to keep redrawing all the triangles to figure out what sides are corresponding. So in your warm-up, so why don't you guys pause this and actually see if you can set up the proportions based off of the similar triangles. So redraw these two triangles in this figure right here, and then we'll talk about the proportion that you set up, and then we'll talk about what patterns that you see. And this will be the last time that you guys have to do this. Okay, so go ahead and pause it right now and work through those two. Okay, so I redrew the triangle. So based off my similar triangles, I could set up the proportion as 18 over x equals x over 29. Okay? And then, so if you haven't done this already, go back and redraw the other triangle. I'm going to pause this and redraw the other triangle as well. Okay, so based off my other triangles, I could set up the proportion as 9 over x equals 6 over 9. So if we start to look at what's happening in these, notice in both of these I have an altitude and I have an altitude. Notice that this altitude x in this first problem is my diagonal, and in the next problem my altitude is 9, which is the diagonal. So what happened yesterday is when you redrew these, every time that you have the altitude, it was always the diagonal of each other, and then the other two numbers were, once you made that 90-degree angle, it was your left side and your right side of that segment. If I look at this 9, this is where it hits right here at D. This is the left side and the right side, and my other diagonal was x times 6. Okay, so that's actually the shortcut that we're going to talk about. So just as a reminder, geometric mean is in a right triangle. It's when an altitude is drawn to the hypotenuse. If it's drawn to the hypotenuse, it means that we have to be talking about a right triangle. Okay? So the shortcut, when you're given an altitude, the shortcut is take your altitude and square it and set it equal to the left side. So left times the right side. Okay, so let's talk about what that looks like. So instead of, in this problem below, instead of going through and redrawing your triangles, trying to figure out your proportion, what we can do is we can take a little bit of a shortcut. So I'm going to say, okay, this is my altitude. I know that because when it hits this side right here at M, it makes a 90-degree angle. So I'm going to use that shortcut, and I'm going to say altitude squared, so x squared equals, and when I hit at M, I create a left side and a right side. The left side is 12. The right side is 33 minus 12, which is 21. So 12 times 21. Okay, so you got your calculators. So this means that x squared equals 252. Take the square root of that, and because I am solving for x and not a side length, I do need to simplify this. So 252, you can go through and try to find your perfect squares. The largest perfect square is 36 times 7. This is my perfect square, so my answer is, the square root of 36 is 6, square root of 7. And that's my answer. Okay, so it becomes more algebraic instead of having to work out your similar triangles to set up your proportion. It would have worked out the same way. Had you gone through and set up your proportions, you would have ended up having x over 12 equals 21 over x. This is where your x squared comes from. This is where your left times right comes from. Okay, so we're kind of bypassing that because it's the same pattern each time. Your other shortcut, which you actually did not use yesterday, and this is going to kind of bypass having to use the Pythagorean theorem, or sometimes you can't use the Pythagorean theorem. If you look at this triangle below, triangle PUS, you know what one of the legs is, you don't know this leg, and you don't know this leg, so there's no way that you can use the Pythagorean theorem. So you're kind of stuck. However, with this shortcut, you're still going to be able to solve it. So this is when you're given a leg, and a leg means, remember, a right triangle, it's the non-hypotenuse side. So this shortcut is to take the leg and square it and set it equal to the short side times the long side. And when we say short and long, we actually mean the adjacent adjacent short, and adjacent long. Adjacent, remember, means the side next to. So what that means is when I look at this triangle, I can see that this is a leg of the big triangle, right? This is my hypotenuse right here. So I take leg squared and I set it equal to, well, if that's my leg, then this side right here, SU, is adjacent to it, and it's my short adjacent side, so it's 12. My long adjacent side is the entire length. It's still adjacent, it's just longer than my other side. So 12 plus 8 is 20. So it's pretty similar to the property that we had before, but instead of doing 12 times 8, we're doing the adjacent 12 and the whole side 20. Okay, so we get that x squared equals 240. Take the square root of both sides. I get that x equals the largest perfect square is 16 times 15. So I take the square root of 16. I get that x is 4 square root of 15. And again, I want exact answers because I'm talking about x, not a side length. And I don't need units. Okay, so let's flip it over and practice some more. All right, number 1, find the values of B and F and the area of triangle ABC. Okay, so if you notice now that we can find all these side lengths, if they're right triangles, we can use Pythagorean theorem. Because they're right triangles, because you can now solve for all the sides, I can now ask you perimeter because you can find all the lengths of the sides, and I can ask you area because you can find these sides and do 1/2 base times height. Okay, so let's start with finding the length of B and F. So I'm going to start with, if I started with B, the problem is I could do B squared because that's a leg, but I don't know this side right here, and that's 2 unknowns. So instead what I'm going to do is I'm actually going to use this altitude, and I'm going to use that shortcut. So remember, that's an altitude, it's inside my triangle. So I'm going to do altitude squared equals, it hits right here at D, and when it hits at D, there's a left side and a right side. The left side is F, the right side is 25. Doesn't matter if you flip-flop those, it could be 25F. Alright, so 60 squared is 3600 equals 25F. Just a linear equation, divide both sides by 25, and you get 144. Okay, so I'm just going to go back up here, and I'm going to write 144 and circle it, so I know that that's that side length. Okay, I'm going to use my other shortcut, and I'm going to do leg squared. This is a leg of my big triangle, so B squared, leg squared, equals the short adjacent side. So if this is my leg, then this is the short adjacent. I stop when I hit that point of where that altitude hit. So 25. And my long is not 144. It's this whole length, this whole adjacent side. So it's actually 144 plus 25, which is 169. So that means that B squared equals 4225. Take the square root of both. And it works out nicely, so I don't have to worry about simplifying. It works out nicely to be 65. So now I know what F is, I know what B is. Now I can find the area of triangle ABC. And I can see that triangle ABC is this triangle. So if I was asking for perimeter, you would have to find all the side lengths and add them up. However, if I'm asking for area, area is 1/2 base times height. This is what I need, and this is what I need. Remember, where they're perpendicular is your base and your height. Okay, so that means I'm actually still missing something. So I need to go through and find the length of BC, which I'll just call Y. And I'm going to, you can use Pythagorean theorem to find this. I'm going to use the shortcut that we just learned just so that we can do it one more time. So if I look at my big triangle, Y is my leg, so that'll give me Y squared equals, because I'm now choosing this side, I look out my hypotenuse from here to here is my short adjacent side, and that's 144. I know it looks long, but it's short, because remember now I'm comparing it to this whole length right here, which is 169. Okay, so times 169. So I get that y squared equals 24336. When I take the square root of that, I get that y is 156. Okay, so now I know that this side right here is 156. So now I can find the area by doing area equals 1/2 times 156. And then that b is over 65. So that means my area equals 5070, and I need to make sure I put feet squared. Okay, so I found F, I found B. I had to find segment BC so that I could then do the area. If I wanted to, I could find perimeter because I could go back and add up all my sides. Okay, all right, next one. Find the values of the variables and the ratio of AC to DC. So, first things first. I see that this is an altitude, and I see that I have a left and a right. So I'm going to start there, and I'm going to say altitude squared equals, hits right here. I have a left side that's 8, and a right side that's 4.5. So 8 times 4.5 gives me 36. So that means that x is 6. That's one variable done. Let's solve. I'm going to solve next for A. A, if I look at my big triangle, triangle ABC, it's a leg. So I'm going to do leg squared equals. The short adjacent goes from B to D. I stop when I hit that altitude. So the short adjacent is 4.5, and the long adjacent goes from here all the way to here. So 8 plus 4.5 is 12.5. 5 times 12.5. So I get that A squared equals 56.25. Take the square root of both sides. I get that A is 7.5. I don't have to worry about simplifying the radical since it works out nicely. Last one. If I want to solve for B, that's also a leg, but this time the short adjacent side is from here to here. So I'm going to do B squared equals, the short adjacent side is just 8, and the long adjacent side goes from A all the way to B. So times 12.5. So this is B squared equals 100, which means B equals 10. Okay, so I figured out A, B, and X. I want to find the ratio of segment AC to segment DC. So ratio is just a fraction, but it has to be in the order that you state it, and it's always numerator over denominator. So AC to DC. So I'm doing AC compared to DC, which equals the length of AC was B, which is 10, compared to DC, which was X, so 6, and then I just need to simplify it and make it 5 to 3. I just want to leave it as a simplified fraction. So the ratio of AC to DC is 5 to 3, or 5/3. Okay? Okay, number 3. Alright. In this problem, I see an altitude right here. I see that at D I have a left side of 9. My right side is taking the whole length C and subtracting 9. So I see that if I do the altitude, I have only one variable, which is C. So I'm going to go ahead and do that one. So altitude squared equals, from D the left side is 9, the right side is C minus 9. So you just really got to know the formulas. So I get 144 equals 9C minus 81. You guys do not need to write out all the steps for solving a linear equation. So you're just going to add 81, and you get 225, and then you're going to divide by 9, and you get 25. So C is 25. Okay, so if C is 25, then 25 minus 9, then this has to be a length of 16. Okay, now I can figure out my other side length, so I'm going to figure out B. B is a leg of my big triangle, so it's B squared, so leg squared equals, the short adjacent side goes from A to D, so 9. The long adjacent side goes from A all the way to B, which I just found to be a length of 25. Okay, So I get that b squared equals 225. I can take the square root of that, and I realize it's a perfect square. So I don't have to worry about simplifying. So that's nice. Okay, take a different color here. Alright, let's solve for a. So if I look at my big triangle again, a is a leg. So I'm going to do leg squared equals. The most common mistakes when you do leg squared is that people tend to do the left and the right, like they do altitude, and they tend to do this part times this part. So just be careful that you understand it's short adjacent times long adjacent. So if I'm talking about A, my adjacent side has to be when I'm talking about my hypotenuse. I cannot say that I'm talking about this as my adjacent side, even though it is, because there's no short and long to that. Okay, so I look back at my hypotenuse. This is my short length, which I figured out was 16. And my long is from B all the way to A, which I figured out was 25. Okay, so this tells me that A squared equals 400. And when I take the square root of 400, I get 20. So A equals 20. So I know A, I know B, I know C, and that's all I need to do. Okay. Move on to the next one. Number 4 says find the value, find x in the length of PA and AR. So we're going to start with x. This right here is my altitude. Okay. So I'm going to do altitude squared. Make sure that I put parentheses around that whole thing. Equals. It hits at k. The left side is 3. The right side is 12. So remember that when you are multiplying this, it's x minus 3 times x minus 3. You don't necessarily need to write it out, but you need to remember that that's going to give you a trinomial. So that gives me x squared. Negative 3 and negative 3, if I add them, gives me negative 6x. When I multiply negative 3 and negative 3, I get 9. If you need to do this to multiply to get that, make sure that you do that. Okay, that equals 36. And I get that x squared minus 6x. I see it's quadratic, so I know I'm going to have to set equal to 0, so I know I have to move the 36 to the other side. So 9 minus 36 gives me negative 27 equals 0. Okay, setting my problem up to factor. My factors of 27 are 9 and 3. This has to be a negative, this has to be a positive. So I get positive 9, and I get negative 3. The negative 3 wouldn't make sense because then my altitude would be negative 6, so this one makes sense. Okay, so I figured out x. I need to figure out the length of PA and AR, so I'm just going to, I don't want to label it as x, so I'm going to label this just as A and this as B. Okay, if I want to figure out this, if I look at my big triangle, I actually have a couple of choices. That's a leg of my big triangle, but I could also do A squared plus B squared equals C squared since I have those lengths. I'm going to leave that up to you if you want to do it, but I'm going to use the shortcut just so that we can do it again. So it's leg squared equals, my adjacent side would be this length of 3, and my whole length would be from P all the way to R, so I need to add those, so that gives me 15. So I get that A squared equals 45. Since I want to know the length of a segment, I'm going to take the square root of that and give my rounded answer. So 6.71. So this means that segment PA equals 6.71 centimeters. Okay. Next part, again, you could use Pythagorean theorem and you could say leg squared plus leg squared equals hypotenuse squared, since I know what x is, but I'm going to use the shortcut. I'm going to use the shortcut just so we can do it one more time. Okay, so my leg is B, so B squared equals, my adjacent side is 12. Remember, I stop at that altitude. My whole side is from R all the way to P, which I found was 15. So I multiply those together. Get 180. Again, I'm representing the length of a segment here, so you guys can take the square root. Don't simplify. The only time that you need to simplify your radicals is when we ask for x. So the square root of 180 is about 13.42. So this means that segment AR is about 13.42 centimeters. I forgot to put about here. About. Okay. So the last problem worked out to be factorable. You should expect most of your problems to be factorable. Sometimes they're going to be linear. Sometimes you're just going to take a square root. But most of the time you should expect them to be factorable, like number 4. Okay, and the idea is that once you can figure out, now you have all these ways to figure out all these side lengths. I could ask you area of a triangle. I could ask you perimeter of a triangle, since you can now find all their side lengths many different ways. I could ask you to compare one side to another as a ratio, like in number 2. But the most important thing is that if you need to keep looking back at this, that you understand these formulas. Okay, understand the difference between left and right, and understand the difference between short and long. Okay, your homework is worksheet number 7, which looks like this. Sorry, it printed funny on 3 pages, but so this is your homework. You're going to need to look at the answers online on Google. And make sure that you follow the directions for each problem. Like in numbers 1 and 2, you can see that it's just asking you to find the value of x, so number 3, 2. But in number 4, it's asking you to find the value of x, a, and b. Okay, and again, if you're trying to find those values of just the variables, they're exact answers, not rounded answers. And then we're going to start getting into more of these types of problems. So this, like number 5 is what we did today and yesterday. Number 6 is going back to what we did last Friday. Okay, so then there's review problems on there. This is not going to be due until Thursday, so you'll actually have tonight. Tomorrow we're going to have we're just going to go over 2 problems because we only have 20 minutes together. And then you'll have tomorrow night to finish up this homework. Okay? All right, good luck. Let me know if you have any questions. Come in and see me.